Well, we are halfway through understanding of fundamental field forces, and it's time to consolidate our understanding with a numerical example. So here's the problem 1 that we shall solve here with whatever you have learned so far. Suppose equal number of electrons are added to the Earth and the Moon so that the electric force between the two bodies just balances the gravitational force. Calculate the total mass of electrons which would achieve this. Take necessary data. So here I have visualized the problem. Let me do a small construction here. Suppose this is the Earth and here is the Moon, and you can see I have joined their centers. Let me repeat once again. It's helpful for spherical objects that you can join their centers and then you can find the distance separation between the two bodies like that. For any other shape, like a non-regular shape, it's not very easy because you can't join the points to be added to get the value of r. That's the benefit of spherical particles, and luckily for us, all celestial bodies, the Earth, the Moon, the Sun, they are very nearly spherical. So, suppose the mass of the Earth, that I am taking to be ME, right? And the mass of the Moon, that is taken to be MM. You can see here I'm using subscript on the thing. The small m is of course mass, E for Earth and capital M for the Moon. This is the masses. We can take the data later at the end when required from some external sources. Now between them, let's say the separation is R. I don't require this R eventually, I call it R. And they are telling equal number of electrons are added to the Earth and the Moon so that the force balances and all these things. So let's assume that number of electrons on the Earth given is N. So total charge is coming out to be, well, minus NE, because these electrons have got charge of magnitude E and the charge is taken to be negative actually by convention. And if N electrons are there on either of them, the charge on either the Moon or the Earth is minus NE, where of course N and E are both positive values. Okay, now these are the charges on them, and see what really is happening is that there are two forces in the picture. First is the gravitational force between the Earth and the Moon because of their masses, and that force is attractive. So let me introduce some arrows here. These are the gravitational force between the Earth and the Moon, which is attractive towards each other, and this of course happening along the line joining the centers of the Earth and the Moon. Now as you have given charges on them, normally the Earth and the Moon are chargeless, they are neutral, so there is no electrical force between them, only force, gravitational force. But now the question is, hypothetically, if you could give charge onto them, then since the charges are similar, both negative, a repulsive electrical force comes in the picture in addition to the gravitational force. So let me introduce some other arrows with a different ink here. This is a repulsive force because both the charges, you can see they are negative. So I'm just having these arrows also, these red arrows, to distinguish them. You can see here, once again you can see the electrical forces also are acting along the line joining the centers of these two spherical objects. So we have got two pairs of forces, green arrows standing for gravitational force of attraction between the Earth and the Moon, and the red arrows, repulsive force, electrical force happening between them in case hypothetically I could add to them equal number of electrons. So you see the condition, they say that the charge given is such that the electrical force between the bodies just balances gravitational force. So let's recall the equations I have given earlier about these two types of force. First of all, gravitational force between the Earth and the Moon is given by capital G, is gravitational constant, into the mass of the Earth into mass of the Moon divided by the square of the separation, which I don't know the value of R, but I don't require it eventually. Similarly, the electrical force between the two celestial objects in case they are given electrons onto them could be written to be, remember the equation, 1 upon 4 pi epsilon 0 into Q1 Q2 by R square. Now in this case the charge on either object is minus Ne. So I'm just putting it, divided by the same R square. R is not changing here, and that's equation number 2. So according to the question, that the two forces have to balance each other. We have already seen the numerical parts only, Fg and Fe, but while Fg is attractive, the green arrows, electrical force is repulsive, the red arrows. So numerically these two things have to be equal to make them balance out. So you go from here, you can also see here that the minus once again become plus, so no problem there. Equating 1 and 2, we could write down that G into mass of Earth into mass of Moon by R square has to be numerically equal to 1 upon 4 pi epsilon 0 n square is square by R square, right? And the first thing I notice that this R square cancel out. I don't require its value. And from here you can rearrange to show that. Be a little careful, I'm just writing it and you'll be just comparing my result with yours. The n can be written to be square root of 4 pi epsilon 0 into G into ME into MM. You can just check these things yourself, divided by E square, the whole thing under square root. So this is what you should be writing here clearly. I'm sure you have all arrived up to this, and just check the result once again, the whole thing under square root, and this is the value of n, the number of electrons to be added to either the Earth or the Moon. And here I require to give you some data, and that I must furnish to you, and I expect you to complete the calculation. Epsilon 0, take the value of this is permittivity of vacuum. The intervening space between the Earth and the Moon is 8.85 into 10 to the power minus 12 SI units, and that is of course coming out to be Coulomb square by Newton meter square. Okay, next is value of G. You know this value, that is 6.67 into 10 to the power minus 11 SI units, that is Newton meter square by kg square.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.